So in this particular question here, we're going to look at applying the remainder factor theorem and factorization of cubic polynomials. So in this particular question here, it says find the values of a and b and factorize the polynomial p of x equals to x cubed plus ax squared minus x plus b, given that p of x is divisible by x minus 1 and x minus 3. If we break this question down, there are a couple things here that we need to do. First of all, we need to find, what are we finding? We're finding the values of a and b. That's our first part. Our second part, it says, and factorize the polynomial. So factorize here is a process or a doing word, a verb. And what do we want to factorize? We want to factorize this entire polynomial here. But obviously first we have to find out a and b because there's a bit of an issue here. It also says given that p of x is divisible by x minus 1 and x plus 3, which means that this here is what's given to us. This here is a circumstance or a condition or information given to us from the question. Now, next step here is to look at this information that's been given to us in blue and break down further what it means. So what does this infer? If it's divisible, then this implies that the remainder is equal to 0. So for our factor here of x minus 1, if we want to figure out what we're substituting into p of x, it's x equals 1. So this means that p of 1 is equal to 0. And essentially what we're applying here, and I'm going to do the same here with x plus 3, let that equate to 0. Essentially what we're applying here is the remainder theorem. The remainder here is equal to 0. We can develop this further by saying it's the remainder factor theorem because the remainder is equal to 0. Now we've got those two pieces of information there. These two pieces of information here will help us find the values of a and b. The reason being is because if we have two variables, then we need two pieces of information in order to find out what our variables are. So let's start off by substituting in p of 1 equals 0 into our equation here at the top. That will be 1 cubed plus a times 1 square minus 1 plus b, which equals to 0. Simplify this. Equals to 0. Okay, because the 1 and the negative 1 cancels out. Okay. The next step here, now we can stop there. The reason why we stop there is there's nothing left to do with it. So we're just going to put that on the back burner and see what else we can do with the question. Our next piece of information that's been given to us, or that we've found out, is p of 3 equals to 0. So let's work with that. Let's play around with what we've got. Negative 3 cubed plus a times negative 3 squared minus a negative 3 plus the b equals to 0. This equates to negative 27 plus 9a plus 3 plus b equals to 0. Negative 27 plus 3 is negative 24. If we take that to the other side, it becomes positive 24. So I'm just going to write 9a plus b equals to negative 24. Now it seems here that we've got two equations. And I'm going to use the method of elimination here in order to cancel out one of the variables. It seems here that it's favorable to cancel out our b's. And we do that by subtracting the two equations, because if we have b minus this b, it equals to 0. So that means we cancel out one of our variables there. So that's what I'm going to do. I'm just going to set it up here. 1 minus equation 1 minus equation number 2. The first thing we're going to do is deal with our left-hand side. So we're subtracting the minus 9a from this first equation here. So a plus b minus, and I'm going to put this in a bracket here because there are two terms that we are subtracting. oh sorry, I did say that this was negative 24, but when we bring it to the other side, it becomes a positive 24. So I'm just going to get rid of that there. It's 9a plus b equals to 24. So when we go to our right-hand side now, it's 0 minus the 24. That's equation 1 minus equation number 2. So we have 0 minus 24. If we simplify this now, we've got a minus 9a, that equals to negative 8a. We've got b minus a positive b, which is 0. Drop the equal sign. 0 minus 24 is negative 24. Therefore, a is equal to 3. Once you have the value of a, we can substitute a is equal to 3 back into one of the equations. I'm going to choose equation number 1 here for obvious reasons. It is easier. So we've got a plus b, which equals to 0. A is equal to 3. Therefore, b is equal to negative 3. So if we look at our question now, we've found the values of a and b. That means we've ticked off the first part. Okay, we can tick that off because we've completed that section. We still have to factorize this polynomial here. So this polynomial here, if we update it, it's equal to p of x equals to x cubed plus our a is equal to 3, so it's 3x squared, minus x, and our b is a negative 3. So what I've done is I've just substituted a and b into there. Okay, and just to make that a bit more obvious, we've found a, which is 3, and b, which is negative 3. So if this is our updated equation, I'm just going to cut this here and bring it down here. We do need to factorize this. So I'm just going to write a little note up here that we need to factorize this question or this cubic polynomial here. In a previous video, I have also already shown you how to do factorization of cubic polynomials. So if you haven't had a chance to watch that yet, please go back and watch that there. Otherwise, I'll continue here. So our first step here is to find the first linear factor. We're going to substitute in factors of this final constant term here. We have options of negative 1 and 1, or negative 3 or positive 3. Obviously, you want to start at the easier numbers here. But just by inspection, if we have a look here, we've got two positive numbers, positive 1x cubed. Oh, well, we've got these two positive terms here, and we've also got two negative terms. So would it be wise, and looking at the coefficients at the front as well, to see how they balance out, would it be wise to substitute in negative 1, or would it be better to substitute in positive 1? Here it would be wiser if we substitute in a positive 1. So let's see what happens here. We've got 1 cubed plus 3 times 1 squared minus the 1 that we're substituting in minus that 3. Let's simplify this here. That's 1 plus 3 minus 1 minus 3. And you can see here the positive numbers, they balance out with the negative numbers. So it does equal to 0 here. This here is our remainder. So what this means is that when we substitute in x equals 1, our remainder is equal to 0. So that means that x minus 1 equals 0. X minus 1 there is a factor. So now we can go across the column and apply our synthetic division. So if we have x minus 1, that means that we're going to use 1 here. We set up the synthetic division algorithm. The x cubed term goes first, then we have our x squared term, then we have our x term and our constant. The coefficients of each of that, looking at our polynomial over here, is 1, 3, negative 1, negative 3. And we follow the algorithm now. So we drag down this particular 1 first, cross multiply with our divisor here, which is 1. 1 times 1 is 1. Follow the algorithm, add the values. 3 plus 1 is 4. Cross multiply with our divisor again. 4 times 1 is 4. Add vertically. Negative 4 plus 1 is positive 3. Cross multiply with our divisor again. 3 times 1 is 3. And if we add this vertically, we should have a remainder of 0. That's our remainder. And again, this checks out because when we did our remainder factor theorem and plugged in x equals 1, the polynomial evaluated to 0, which is our remainder. Okay, so this is our x squared term, our x term, and our constant now, since the terms reduced by a power of 1. So we can rewrite our polynomial now from x cubed, originally x cubed plus 3x squared minus x minus 3. We can rewrite this now to the product of our factors, which is x minus 1, and our quadratic factor, which is x squared plus 4x plus 3. One more step, we can factorize this quadratic expression here using the cross method. It's not the only method, but it's my method of choice. And we end up here with 3 linear factors, the product of 3 linear factors. Remember reading our brackets horizontally. X plus 3 and x plus 1. Okay, so that's all factorized now, which means when you feel like you've answered the question, go back up to the question. Make sure you tick that off. Have we factorized? Yes, we have. So we've factorized here. We've found the values of a and b, tick, and we've also factorized the polynomial as well. Let's go back here. This section here, we did factorize it. I'm just going to get my a lighter color here, and maybe green. Box this up. Yep. To clearly indicate to the assessor or the person marking your paper that you have answered the questions and fulfilled the criteria.